Hi everyone, in this video we're going to compare undirected and directed graphs and explore what makes them different. Let's start by looking at two graphs, one undirected and one directed. Both graphs have four cities as vertices, Paris, Berlin, London, and New York. In the undirected graphs, the connections between the cities, called edges, go both ways. The cities are connected as follows: Paris, Berlin, Berlin, London, Berlin, New York, London, New York, New York, Paris. These edges indicate that the travel is possible in either direction between connected cities. On the other hand, in the directed graph, the connections have a specific direction, meaning they only go one way. Here's how the cities are connected: Paris to Berlin, Berlin to Paris, Berlin to New York, London to Berlin, London to New York, New York to London, New York to Paris. In this graph, you can only travel in the direction of the arrow, from one city to another. Next, we'll look at how these graphs can be represented using adjacency matrices. For the undirected graph, the matrix shows whether there is a connection between two cities with a 1 for yes and a 0 for no. Because it's undirected, the matrix is symmetrical, reflecting that each connection works both ways. For the directed graph, the matrix is asymmetrical. It only shows a 1 where a connection exists in the specific direction indicated by the arrows. So Paris might have a 1 going to Berlin, but Berlin to Paris would only show a 1 if there is a direct connection. Finally, we can represent these graphs using linked lists. For the undirected graph, each city, or vertex, is linked to the cities it's directly connected to. Since the connections are bidirectional, each pair of connected cities will reference each other in the list. For the undirected graph, each city, or vertex, is linked to the cities it's directly connected to. Since the connections are bidirectional, each pair of connected cities will reference each other in the list. In the directed graph, the linked list represents the direction of each connection. For example, Paris may point to Berlin, but Berlin will only point back to Paris if there is a direct edge for the specific route. And that's a comparison of directed and undirected graphs. We've seen how they differ in terms of connections, adjacency matrices, and linked list representations. Understanding these differences is crucial for working with graphs in computer science. Thanks for watching.